Topic of volume studies, and we have talked about volume studies on segments, intersections, limited network, state network, and the last thing which we were covering was specialized counting studies which are related to an entire zone or an area. And there are three different types of these studies: origin, destination, screenline, and Cordon counts. The last one which we discussed was origin destination, in which you collect a sample using one of these methods, and then you try to adjust this sample to give you the actual counting. Okay, so we need to do an actual counting as well, and we were using these factors, okay, which is the actual count upon the count which you are getting from your sample. So when actual becomes very close to the counting or the sample, that's where we stop. So I explained all the iterations here. The next type of specialized counting study is a cordon count. Okay, cordon means a boundary. Okay, when we say an area is cordoned off, that means they have put a boundary around that area. Okay, now the three specialized counting studies: origin, destination, cordon count, screenline count. Okay, you have a map in front of you. In all three cases, you have a map in front of you. Okay, on that map you select your zones yourself. Okay, we are selecting these areas. So for example, this is origin, destination. Okay, so this is my entire area. Okay, and I'm dividing it into 4 pieces. Okay, where am I doing it? On the map. So there may not be any physical boundaries there. Those are done. Okay, so these are the boundaries which we draw on the map for our analysis. Okay, so why it is more important here? Because I'm saying cordon count, and cordon means a boundary. Okay, so it doesn't mean I will go around the area and make a wall. Okay, nobody would allow you. So this is, you open your map and you mark, this is my area of interest, and around this area I will make a boundary on the map. I'll mark the edges of my area on the map. Okay, and those edges are called as cordon. Got it? Clear or not? Okay. Now I'm doing it for traffic study, right? I'm doing it for traffic studies. So obviously this area cannot be any area. I have a building somewhere which nobody is using for last 20 years. I'll not make a cordon around that building, right? Okay, but it has no effect on traffic. Okay, so the area around which I am building the cordon should be an area of interest in terms of traffic. It must have some significant impact on traffic. Got it? Okay, and normally these areas are called as CBDs. Okay, central business districts. Central business districts. Now business does not only mean commercial here, any type of business which is creating traffic. Okay, could be this area as well. Education is business, right? Best business along with that, right? Right or wrong? Okay, so we build a boundary, we pick up a map, we select, okay, this area has too much effect on traffic, is generating too much traffic, and this is the boundary around this area. Okay, and now our study is to see how many people come into this boundary and how many people go out of this boundary. Got it? Okay, so since I'm making the boundary, I have to keep few things in my mind, because it's my choice, right? How much area I will put under the boundary, it's my choice. First of all, the size, or the most important concern is the size. How much should be the area within your cordon, within your boundary? Okay, You can go to two extremes. You can make it very small. It will be easier to manage, right? A small area, it will have less streets and intersections, right? Less crossing points, easier to manage, okay? But you will not cover all the businesses which are causing the traffic, okay? Imagine something like Seaf district, for example, okay? And you make a cordon around Seaf Mall, let's say, okay? Or you make a cordon around, what is that? I stopped going there, so I don't remember the name. The other one, the other big mall, what's the name? Center or? City Center, yes. Okay, so you make your boundary around that, okay? But obviously, you know, it's easier to manage. The boundary around only city center, easier to manage, easier to collect data, but that is not the only thing which is attracting traffic in that area, right? So you are not covering all the traffic generators. Okay, you are not covering all the traffic attractors. Okay, so this is when you go too small. Okay, and if you go too big, okay, then you know I already told you the first problem. If the area is bigger, what will be difficult? Managing it. Data collection will be more, right? You have more points of data collection, right? And the second problem, okay, somehow I say, okay, I'll manage data collection. I have too many sensors and I have many people. I can engage all of them and I will do the data collection. Okay. This time in traffic engineering, I have two sections. So I have many students, something like this. Okay. But that other problem is when you take an area which is too big, everything which is inside the area is not the same type now. Okay. Anything which is inside the area is not the same type. Okay, going back to the example of Seaf district now. So there is one side of the district where you have the city center and the Seaf mall and the other malls and so on, right? And then there is the other side of the road which has not the same businesses. They have residential and so on, right? Okay, so if you cover all of them under one boundary, within one boundary, then you are not sure why the traffic is coming to this area because you mixed everything inside. Okay, so when you are making boundary for your cordon counts, the most important thing you need to keep in mind is the size of the area. So you need to balance between too small area in which you will miss many businesses or too big area in which you will mix many businesses. Okay, so we don't want to miss it and we don't want to mix it as well. Okay. So you have to select your boundary in a way that all businesses of the same nature are covered. Got it? Okay. Second thing, which is from the convenience point of view. Okay. When you are marking the boundary in your around your area, so take the example of, let's say, the Seaf district. Okay. So you have the main highway on one side of the district, right? When you have to enter the, if you are going towards Seaf, you are on the main highway. Okay, I forgot the name of the highway. Sheikh. King Faisal? Sure? Okay. King Faisal Highway. Okay. Now, do you agree that one edge of the area is along this highway? If I mark this area in my map, one line will be along this highway, right? Okay, because this highway is the edge of the area, right? So doesn't it become my cordon? The highway becomes my cordon, right? Because it's already around the area. Okay, so it's a feature which is already around this area. Okay. So whatever line I will mark will be along this feature. Okay. So my cordon will be going with King Faisal Highway, or it will be on King Faisal Highway, right? Okay. Now it's a major highway. It's a major highway, right? You cannot cross it from anywhere. There are few points. If you miss one point, maybe the next point will be after 2 kilometers or 3 kilometers, right? Okay. Agreed or not? So if I have a feature which is already at the edge of my area. So that feature becomes my cordon. And another advantage I will have is, because this feature is very prominent, people cannot cross it from anywhere. So my crossing points will be less. Points from where people can enter from this side will be few. Okay, so maybe you have 2 entry points from this highway onto the area. Agreed? Okay, so if you have a prominent feature, an important feature, a feature which could be a highway, which could be a river, it could be a railway line, something like this, okay, which is already at the edge of the area. Okay, don't avoid it, put it as part of your boundary. Okay, and the advantage will be that on this side of the boundary the crossing points will be very few. Got it? Clear? Okay, so you have a map in front of you. You want to select your area of interest around which you will put a boundary. The area of interest should combine all the businesses of the same nature, not more, not less. Okay, and then you look at the boundary or the area itself. Do I have features which can act as a boundary? Obviously, if I don't have features, then no problem. I will make my boundary anyways. I'll not leave it. Okay, but if I have a feature, I will make that feature part of my boundary so that I have less crossing points. Got it? Clear? Okay. Now, if I have a feature, I will make that feature part of my boundary. What will be for the other sides? That main highway is not on all sides of the area, right? Okay. So on the other sides, I will make boundary myself. Okay. So for example, I have this area. On this side, I have a main highway or a bridge. So this is part of my boundary. Okay, I don't have any feature here. Okay, so I will make this line myself. Okay, so how do I make this line? Let's say there is an intersection here. Okay, I have the choice. I can make this line at the intersection. I can make this line before the intersection or after the intersection. Okay, I have the 3 choices. It will not make much difference here, right? Only few hundred meters here or there. It will not change the area too much. Getting my point? Okay. So what should I select? On the intersection or before and after?
After.
Why?
Because we want to have the vehicles who cross the intersection.
Okay. Why not at the intersection? Before and after will have the same answer. But why not at the intersection? Why not at the intersection? I already mentioned the answer first when I was mentioning the size of the area. Which one is easier to manage? This traffic or this traffic? Which one is easier to count? This one or this one?
Straight traffic.
Okay, that's straight traffic. Okay, and the other thing is straight traffic is more accurate as well. You are either entering or leaving. There is no turning here. Okay, intersection, then you may have a chance that somebody is taking left turn and going back into the area. We don't know. Somebody is taking a U-turn and so on. Okay, so another thing which you have to keep in mind for the position of the boundary is we make it on the segments, not at the intersection. Okay, because it's more accurate and more convenient. Got it? Clear? So size of the area, incorporating the objects within the boundary, and the position of the boundary where you have the choice. Okay, so this is what I've already mentioned. Okay, this is data from a cordon count. Okay, the main aim of the cordon count is to find out accumulation of vehicles within the area. Okay, how many vehicles at a time are present within the area. Okay, these counts are used for area-wise planning. How many parking spaces I need in the area? Should I introduce new bus service in the area? Should I allow trucks at this time in the area, and so on and so forth. Okay, so area-wise planning is done using these counts. Okay, how do we do them? First of all, you start the count where you start the count when the businesses are not open yet. Okay, the businesses are not open yet. The area activity has not started. So if it is educational area, before the school time. If it is if it is office area, before the office time. If it is commercial and mall area, then like in the afternoon or something, where many people don't come. Okay, because some of the malls are open, like they are only closed for 2 hours of the day, right? So you try to start when the activities have not started. Why? Because at that time vehicles entering and vehicles leaving will be very few. Okay, so your starting count will be accurate and convenient. Okay, because not too much change is happening. Okay, so at that time what they do is they go around the area and they find out how many vehicles are already within the area. Okay, if they find any vehicles entering or leaving, it will be very few because activity has not started. Okay, you will add them, obviously you will add them. Got it? So we are counting how many vehicles enter, how many vehicles leave, and how many vehicles are already in the area. The starting point is basically for this reason, because if too many vehicles are entering and leaving, this count will not be constant, obviously it will change too much, right? Okay, so we start when these two are not changing much, so this will be almost a constant number. Okay, even if you miss 2 or 3 vehicles plus or minus, doesn't matter, you are getting almost the same thing. Okay, clear? So the first count is basically for vehicles which are already in the area. They are parked somewhere or they are going within the area on some streets, you will count them. Okay, clear? Then the real counting begins for the vehicles entering and leaving. So if you have 3 entry points, you will have 3 observers, 1 at each point. If you have 3 exit points, you will have 1 observer, 1 at each point. Okay, or more than 1, whatever. Okay, easy for counting. But we are counting at every entry point and we are counting at every exit point. Okay, and these are the hourly values. So in 1 hour, 100 vehicles entered, 20 left. Okay, my initial count gave me 250. So 250 were already there. Okay, so now what will I do? 250 were there, 100 more entered, and 20 left. So 250 plus 100 which entered minus 20 which left. So how many vehicles are now in the area? 300. Got this? Clear? Okay. Next one, 330 are already there, 150 more entered, added, 40 left, subtracted. Okay, how many are there in the area? 440. Okay, now you can look at the counts when the activities have started. The vehicles entering are more, leaving are very few, right? Because this is a start time. Okay, this is what it should be. So when this happens, number of vehicles in the area are what? Increasing or decreasing? Increasing. Okay, and then in the evening it flips. Okay, now the entering is less and leaving is more. Okay, so number of vehicles in the area are increasing, decreasing? Decreasing. Clear? Okay, in the end we get 270 in the area and my initial count was 250, right? So they are very close. Okay, this shows that you completed the full cycle. You completed the full cycle. If you stop somewhere here, okay, because you are too tired, you have a football match, you have a movie to watch or something, okay, then you can see the difference is very high. Okay, so the cycle of the activity did not complete. Okay, so the main thing is we try to complete the entire cycle. Then you can plot this sort of a graph and you can see where is the peak hour, when should I expect most number of vehicles in the area. Okay, and you can see they have made the distinction between cars and trucks. So you can do this as well. You have to do the counting, obviously. You have to count trucks separately and cars separately. In some of the areas, the congestion or the problem is because of heavy vehicles. If you go towards port, for example, in the port area, the problem is because of trucks. If you go towards the education area, the problem is because of buses. Okay, so then you do the separate counting so you can see when is the peak time for trucks and when is the peak time for cars. You may do some planning for them separately. Got it? Okay, this is actually from a study done in Bahrain, and then now you can see the problem of cutting it short. Okay, you can see accumulation is going up, up and up. It reaches this point. After this, where can it go? It can go up, it can go down, I don't know. Okay, because the study is not completed. Got it? Okay, so this is why I said that you need to finish it. This is a representation of a cordon count. So you can see the boundary of the area, nice square boundary. You can see the crossing points, and the crossing points are basically what? These lines are what?
Direction.
Huh?
Direction.
The arrows are the direction. What are these lines? What are they representing in the area? What they are actually? Roads and streets, right? Okay, so they are roads and streets. Okay, so you see two-way roads, you see some of them are one way. Okay, and at each point you have a separate count. So this is more detailed. The table was showing the total only, right? This is more detailed. So now you can actually see which highways are having more traffic. Okay, all of these vehicles are entering, but from where usually are they entering? What is their peak point? Okay, clear? Okay. So you can go in as much detail as you want. You can keep like a one table, total only. You can separate cars and trucks, or you can do something like this, count for each point separate. Okay, but in all these cases, the area is important. The area is important. Okay, and we want to see how many cars are going into the area. The last type of specialized counting study is a screenline count. Okay, a screenline count is a mini origin destination study. It's a mini origin destination study. Okay, the origin destination example which we did, how many zones it has? 4, right? A screenline count is an origin destination study for 2 zones only. A screenline count is an origin destination study for 2 zones only. Okay, so again you have the same things which I mentioned earlier. You have the map in front of you. You will make your boundary. If there is a feature between the 2 areas, it should be part of the boundary. Okay, so the crossing points will be less, and where you have the choice, you will make the boundary on the segment, not at the intersection. Okay, so all these things which I mentioned earlier, they apply to screenline as well. Okay, wherever you are making the boundary, these points will apply, whether it's for cordon count or for screenline count. Okay, so for example, yeah, so there is this feature here which is between the 2 areas. Okay, so I make my screen line this feature. Okay, according to them it's a river, but there are too many crossing points on the river, so all of them may be swimmers or they are using boats or something. Okay, now a screen line count, there is one extra feature which you have to look. Now whatever we discuss for origin destination, everything, it applies to screen line as well. Okay, but in origin destination we have a bigger area, so we make more zones. So maybe you are doing origin destination for the entire Bahrain. Okay, and you have 50, 60, 70 zones. It can happen, but screen line only 2 zones, right? Okay, when you have origin destination, since you are covering the entire area, people who may not belong to this area, belong meaning not like expats, belong meaning they are not traveling to this area or they are not coming to this area. Okay, the possibility of having these people is very low because you have already covered a very large area. Okay, so if I cover the entire Bahrain, okay, then the possibility that somebody could be from outside Bahrain and he doesn't want to be in Bahrain, he wants to go somewhere else, that possibility is very, very low now. Okay, but in a screen line count, because your area is small and you have only 2 zones, this possibility is very high. Okay, so somebody could be coming from here and he is just crossing and you go somewhere else. Okay, so because of the smaller area, you will have a lot of external crossings. Okay, so your data will now have a significant number of external crossings as well. People who are just crossing, they are from out of these 2 zones and they are just crossing. Got it? Clear? So this is the thing which you will not find often in origin destination. Okay, but this one will have. Okay, so you have external crossing, you have internal crossings, the crossings in which we are interested in. Okay, people who are crossing between these 2 areas. Okay, they are called as internal crossings. If you add them together, you get the total number. Got it? Clear? Now, you see the pattern here. Gross is total, obviously is the highest number. Then you have internal, this, and you have external. Now, if you compare internal and external, which one is higher? Internal is higher, right? Okay, and should be higher. Should be higher. Okay, because these trips are what? They are unknown. I don't know from where they are coming. And even if I know the area, it's not of any interest to me. I'm interested in what? These 2 areas, right? So if my external crossings are very high, that means my selection of area is not good. I am doing a study in these 2 areas where most of the people are not even coming. Got it? Okay. So internal should always be very, very low as compared to the external crossings. Okay. If you have selected your area and the screen line properly. Clear? Clear? Okay. This is a sort of a screen line count which they do at King Fahd Causeway. You can have a look. It's available online. So they count every day how many vehicles are crossing, right? How many vehicles are crossing between Bahrain and Saudi. Yes, it's a screen line count. One area is Bahrain, the other one is Saudi. Entire Saudi or whatever, Khobar, Dammam, whatever. Okay, so this is sort of a screen line count. Okay, and now you have here you have the advantage that your screen line is what? What is your screen line? Huh? What divides these 2 areas? What divides Bahrain and Saudi? Huh? The causeway divides. The causeway connects the sea, right? Okay. Sea or whatever the boundary you have. Like these areas have a boundary, right? They have a political boundary. If you cross this, you are in Bahrain. If you cross this, you are in Saudi, right? Okay. So this screen line has a very convenient and very prominent feature. Okay. So nobody can say, no, I will do a screen line count between these 2 areas, but I will make my boundary in Jisra. Jisra. Yeah? Same? Whatever. If you don't mind. Okay. I will make my boundary on Jisra. Okay. Or I make my boundary on the Dammam highway. You cannot say this. Okay. Because you will miss the natural boundary you have already. Okay. So okay, you can have a look at these questions from the 2 books for your practice. Okay, now we are moving towards a very important topic because this will be covered in the last part of your term project, and obviously this is not included in the other exams, so most probably it will come in the final as well. So a lot of things depend upon this topic, which is to calculate the capacity and level of service for highways. Okay, and in this course we are calculating capacity and level of service for uninterrupted flow facilities. How do we define uninterrupted flow facility? Tell me. No intersections mainly, okay, or no interruptions, okay, and these interruptions must be permanent and external, and an intersection fits this definition completely. So now we will be covering the other outcome of this course, which is that you know how to calculate the capacity level of service for different types of highways. So even within uninterrupted flow facilities, we will not cover one type of highway. We will be covering 3 types of highways here. Okay, you can have a highway which does not have an intersection or interruption from start to end. Okay, that is uninterrupted. Yes, but the definition also extends to those highways which have intersections, but the spacing between the intersections is more than 2 miles. Okay, so if the spacing between the intersection becomes more than 2 miles, then it is also considered, or that part is considered as uninterrupted flow facility. Okay, so without intersection, without interruption is already uninterrupted. Okay, but on certain highways, some parts can be considered uninterrupted. What parts? Where the intersection have more than 2 miles between them. Got it? Okay, and there could be intersection could be of any type. Stop sign, roundabout, signal, whatever. Now, including this extension, we have 3 types of highways. Okay, the first one is a freeway. Freeway is highway without intersection, a highway which does not have intersections. Okay, second one and third one, they are included when you consider this factor. Okay, so multi-lane highways and rural 2-lane highways, they have some parts as uninterrupted. Okay, not the full highways are, the full highway is not uninterrupted, but some parts of these highways are uninterrupted. Which parts? Which have more than 2 miles in their intersections. Okay, no intersection, we call it freeway. If there is intersection, then we have to look at the spacing. Spacing more than 2 miles, it can be multi-lane highway or 2-lane highway. Okay, and what is the difference between these two, the last two? Okay, the number of lanes. This one is only 2 lane, this one is multi-lane. Okay, now if you see here, we are saying rural 2-lane highway, right? Did we say rural multi-lane? No. Did we say rural freeway? No. So why rural is here? Is because of the condition. Okay, 2-lane highways in urban areas. Urban areas means cities. They have more population. Okay, so to find a 2-lane highway in an urban area which fits this description is almost impossible. You cannot have a 2-lane highway which is without any intersection and which is so long in an urban area. Yes.
There's speed bumps considered as interruptions?
No. Okay. Interruption is something which is because speed bump will decrease the speed of the highway itself. That's why. The interruptions are external. You are stopping because somebody from other side is coming or something. Okay. So that's why rural is there, because to find a 2-lane highway in urban area without intersection for so long is almost impossible. Okay, clear? The method for calculating capacity and level of service, which is followed worldwide now, is given in Highway Capacity Manual. The manual is published by TRB, Transportation Research Board. It's a very well-known organization. They do a lot of work in the field of transportation. And one of the things which they are doing is publishing this manual. And now they are, since last 2-3 editions, they are publishing the manual after every 6 years. The latest one is 2022. So by this trend, we are expecting the next one by 2028. Okay, if you guys want to stay till that time, no problem. You can see the maybe the new manual as well. Okay. The earlier versions of the manual did not have any software. The calculations were easier. Later versions, calculation became more complex, so they needed some sort of software to do it. They made their own software, which was called as highway capacity analysis in 2000. Then later on, the manual became so popular that other softwares started incorporating their calculations in their software. Okay, so now we don't need a specific software to do the manual calculation. This manual calculation, not the manual by hand. The calculation of this manual. Okay, you pick up any software which does traffic simulation, and that software is following the procedures given in highway capacity manual. Okay, so some softwares I mentioned here. We got Vism now recently. Once installed, I will show you. I don't know when, but maybe. Now we are looking at, you already know the definition of capacity, right? What is the definition of capacity? Anything else? Maximum volume. Okay, this is a rough definition and the concept is correct, but in the manual now they have formalized it. Okay, so now they are saying, okay, the capacity of the road should have this. First of all, they are saying capacity is not volume. Capacity is maximum flow rate. Okay, capacity is not maximum volume, capacity is maximum flow rate. Okay, now are these two different or same? Volume and flow rate, are these same or different? Is volume and flow rate the same thing, or are they different? They are different, right? Okay. Which one depends upon a shorter time period? Flow rate. Okay. So this is the critical thing about this definition. If you take the definition of volume, the capacity is maximum volume, then you are ignoring the traffic variation in small time periods. Okay, flow rate covers that. Okay. Secondly, they have given us a general definition which can apply to even bus systems as well, or railway systems as well. But now in that case, they change it to maximum flow rate of persons, not cars. Okay. Sorry.
Persons or vehicles.
Yeah, but you see, if there's a bus system, we are not actually looking for maximum number of buses. We are looking for maximum number of people who can use the bus. Because if you go for maximum number of buses, you have buses going like this. People can just walk, right? So it is always for a lane, it is always given per lane. They have mentioned roadway as well, but if you go and look at the units in the manual, it is always per lane. So it is always flow rate, it is always per lane. It can be people, it can be vehicles. Okay, if they are vehicles, they take it as cars. I will show you these things later on as well. Yeah, they are saying capacity is an expected value. The actual value can be little bit more or less. Okay, so they are accepting that our calculations can have some error. Okay, so it's not 100% accurate or 100% precise. Okay, so it's an expected value. So we should have some margin of safety in that case, because the actual capacity can be less. Got my point? Okay. And another thing which we have discussed earlier is capacity remains the same for a uniform section. So the point at which the road properties change, the capacity will also change. Got it? Okay. I have this point. On this point, the road has X properties. In the next millimeter, the properties change, any property. So the capacity of this point and the next point is not the same. Clear? If properties do not change for 100 meters, capacity is same for 100 meters. If properties do not change for 1 kilometer, capacity is same for 1 kilometer. Got it? Okay, so it could be, it could change every point, or it may not change for a very long distance, depending upon the road properties. What are the things which change the capacity? First thing is the road itself. If you have 2 lanes, now you put it 3 lanes. Earlier the gradient was 1%, now you are putting it 2%. So this will change capacity. Okay. Second thing is the environmental conditions, weather conditions, visibility, light. Okay. So these things also affect capacity. Traffic conditions, what type of vehicles you have, what percentage of trucks you have. Okay. Do you have big trucks, small trucks? Okay. Do you have bikes? Okay. So these things also affect capacity. And then we have the last one, which is the control conditions. The control conditions, which is does this road have signals? Speed breaker, okay, speed bump. It does not change the type of highway, but still it's a control, right? You are trying to control the speed of the vehicle. Okay, so whenever any control conditions change, then capacity will also change. Yes.
Traffic affects the demand or the capacity?
Say again.
The traffic affects the demand or the capacity?
The traffic mix, we mean the traffic mix. What usually mix of traffic we have on this highway. Okay, so that affects the capacity. The capacity. The demand is affecting capacity. The demand is the type of demand you have is affecting capacity. Clear? Okay. These are capacities under ideal conditions at uninterrupted flow facilities. We have 3 of them: freeways, multi-lane highways, 2-lane highways. Okay. You can see the values for these highways depend upon the speed. Okay. Speed changes, capacities also change. Clear? All of them have the same units, which is passenger cars per hour per lane. These are the standard units for capacities in highway capacity manual. The highway capacity manual gives you capacities in passenger cars per hour per lane. Okay, but per hour doesn't mean it's volume. Per hour means it is flow rate. Keep in mind. Okay, volume is also per hour, flow rate is also per hour. This one is what? Flow rate. Okay, clear? Because the definition says it's flow rate. The definition says it is flow rate. Okay. So for freeways, multi-lane highways, it depends upon the speed. Okay. Speed decreases, capacity decrease. Okay. Speed increases, capacity increase, because speed means the design of the road is getting better, right? More speed means what? Better design. Got it? Okay. So capacity would be naturally higher. A better road will have more capacity, right? Okay. Then we come to 2-lane highways. 2-lane highways, total capacity, whatever speed you have. Total capacity is, now you can see it's not per lane, right? This is total. Total, both directions. Okay. If you go into one direction, 1 lane, capacity of 1 lane on a 2-lane road ideally is this much. This is one direction. Okay. So the total of both directions can go up to this much on a 2-lane road. For one direction, it can go up to this much. Okay. Now, is it making sense? One direction goes up to 1700, and both combined only 3200. If one direction can go 1700, then both directions should go up to how much? 3400, right? 1700 multiplied by 2 is 3400. Okay. This is, we will study it later on as well. 2-lane highways, you have traffic going in different direction very close to each other. Okay, there are no lanes between you and the other direction. Okay, so one direction has an effect on the other direction. When one direction is full, the other people in the other direction, they also become slower and more cautious. Okay, so on a two-lane highway, there is a directional effect as well. On multi-lane highways, freeways, there is no effect of one direction on the other, because one direction itself is very large, it's very wide. Okay, so something which is far, you don't feel the effect, right? Something which is farther, you don't feel the effect. But something is near and it is going in the opposite direction, and it is full and it is congested and there's a long queue, then you feel the effect. Okay, you can see it if they are doing some construction work on the side of the road. Okay, and if they are very close, it's the same highway, they are not doing anything on the road itself, the road is same as it is, but now there's a barrier on the side of the road. People in that lane feel the effect of this barrier. Okay, it's not in their way, it's on the side. Okay, but the driver psychology is something is very close, it has an effect on your driving. Okay, clear? Some of you are thinking no. God bless you. Okay, then we come to the concept of level of service. Okay, or loss. Loss? LOS. Okay, don't call it loss, you will lose it. Level of service. We know two conditions of traffic. Okay, level of service defines different conditions of traffic. LOS defines different conditions of traffic. We already know two conditions of traffic. Okay, one is called as free flow. Actually, we know three. We know three conditions of traffic. One is called as free flow, other one is called as capacity, and the third one is called as traffic jam. We have studied them earlier, right? In the first lecture. There was free flow condition, there was capacity, and then there was traffic jam, right? Okay. Which one of them is the best? Free flow, right? Okay. Free flow. Capacity, what about capacity? Second best, right? Because the flow is still moving. Okay. But now if you come to design, okay, let's say you are doing building design. You are doing building design. Okay. Will you consider a condition for your design, the load for your building design? Will you consider that the capacity of the building should be exactly equal to the load? No. Okay. This is, so capacity is out of the way, right? I cannot use it for design. Traffic jam, obviously, it's a failed condition. I cannot use it. Okay. What about free flow? Again, going back to the building example. Free flow means what? No load. So will you design a building which has no load? You guys will do, obviously. You will do. In your senior projects, you will do, right? Nobody is going to make this building which is designed by you guys. It's a zero load building. You will do it. Okay. But practically, no, right? Okay. We don't want a building which has zero load. So that is free flow. That is free flow condition, right? A road which has no traffic. Okay. So we don't want a road which has no traffic. We don't want a road which has traffic jam. And we don't also want a road which is almost equal to capacity, right? So I need some other traffic conditions for designing. I need to define something in between them, right? Something which is not traffic jam, something which is not free flow, and something which is not capacity, something between them, right? Between capacity and free flow. Capacity, after capacity is traffic jam. One step. So there's nothing between. Okay, the only between you can have is between free flow and capacity.
But if you want to increase the capacity to avoid traffic jam, like apply the safety factor to the capacity.
Right now we are going for the design. Okay, so there is no capacity right now. The increasing will come later, right? Okay, I designed the road, now there's traffic jam, I will try to increase it. That will come later, right? But right now I'm just designing it. Okay, So the thing is, you have demand, and now you are going to design the road. Okay, you want your demand to be less than the capacity, right? How much less? Not free flow, something between, right? Okay, so this is why the level of service concept has become very popular, because it gives you more levels than the extreme conditions. Free flow is an extreme condition, capacity is also an extreme condition, and after capacity you have failure, the traffic jam. Okay, so level of service gives you intermediate traffic conditions. Okay, it's basically a scale to measure traffic condition. It's a scale to measure traffic condition. Okay, and for your convenience, very easy to remember, the scale goes from A to F. Huh? Yes. Okay, but it has E as well. You guys don't have, right? And it doesn't have plus and minus, C plus, D plus. Okay, it doesn't have that. Simple. Huh? F minus. Okay. I saw it in a video or something. The student was so bad, the teacher gave him F minus. So, yes, it should be there. Okay. So the definition of level of service, I already gave you the idea. It is basically a scale of measuring traffic condition. Okay, and this is the formal definition. Okay, so it depends upon traffic condition means how traffic is moving on your road, how traffic is operating on your road, and you can do it for each lane separately. Each lane can have its own level of service. Okay. Yeah, another benefit of level of service, I already gave you one benefit, which is to have intermediate traffic conditions, something between the extremes. Another benefit of level of service concept is that it can, or it does include things which are not easily measurable. Okay, it includes things which you can measure. For example, speed and travel time, we can measure, right? Okay, we can measure speed and travel time. Some of you have already done it. But there are things which we cannot measure. For example, freedom to maneuver. How freely I can go from one lane to the other. Okay. How comfortable I am when I am going on this highway. Okay. How convenient it is for me to get on this highway and go into a different direction and, you know the thing, huh? Honk at somebody and go over the shoulder and the median and hit somebody and so on. Okay, all those things you cannot measure it, right? It's all in your head. So level of service includes these things as well. Okay, so there are two benefits. One is providing practical usable traffic conditions for design, and the other one is incorporating important factors for the drivers which you cannot measure. Okay, as I already mentioned, it goes from A to F, right? There is no F here, because then guys, you will not read these slides. That's why the F is gone. Okay, but this is a smaller definition of each level of service. There's a more detailed definition coming later on. A means very high operating condition, free flow speed, free flow conditions. Okay, B is considered as practical capacity for rural, and C is considered practical capacity for urban. Then you have D, which is maximum sustainable flow, maximum continuous flow. Okay, just before capacity, just before capacity. Then you reach level of service E, which is the capacity stage. Okay, so let me rephrase it. Free flow speed. Okay, no interruptions. You are choosing your own speed according to the conditions of the road. Okay. Level of service B. If you are in an open area and if you have few vehicles, so you can see the vehicles more clearly, right? If the area is open, like a rural area, you can see the vehicles to farther distance and more clearly, right? So if I start seeing vehicles in an open area, even few vehicles will have an effect on me. Okay. And when these vehicles have an effect on me, I'll reduce my speed, right? I'll not go at free flow. Okay, so that is the level of service B. Level of service C is when the same thing happens in an urban area. Okay, well, urban area is already very congested. Okay, so you already see the buildings and so on and so forth. Okay, so your speed is already lower. So even if you see few vehicles in front of you, you are already going at a very low speed. Okay, so you will continue. Okay, so in urban areas, the stage of reducing the speed comes later. Okay, and that is called as level of service C. Okay, so A is free flow speed, your choice. B is reducing the speed in open area. C is reducing the speed in an urban area, congested area. D is when you are already reducing the speed, but you are at least moving. You are moving at a slow speed. Okay, and E is you have reached capacity. Capacity means full, right? Capacity means full. Okay, ideally capacity should also have continuous movement. It should also be sustainable. It should also be continuous. Okay, but because of driver behavior, we have to check our phones. We have to sometimes we remember, oh, I should be in the right lane and I'm in the third lane on the left. Okay, so we remember all these things, right? Okay, so because of this, the flow at capacity is never continuous, because what will happen? I want to change my lane. I am at capacity. If I want to change my lane, somebody has to stop for me, right? So that's why E is capacity, but it is not continuous flow. Practically, it cannot be continuous. Drivers have to do these things. Okay, so yeah. Okay, I'll continue then next time.